Striking a gong, the metal vibrates, producing its unique sound. The gong used in boxing matches, or the cymbal often heard in various TV programs, are the examples. Such a sound also occurs when two black holes collide and form a new black hole. However, the sound appears to be gravitational waves, not sound waves. Then, what kind of sound does a black hole's gravitational wave make? For the first time in history, we've successfully detected the sound of colliding black holes. This is a momentous event, something previously impossible with existing technology. It may sound out of the blue, but we also confirm that black holes have no hair. Per general relativity, black holes only show mass, charge, and momentum. These characteristics of a black hole are referred to as the no-hair theorem. This started with physicist John Archibald Wheeler's statement, "Black holes have no hair, hence they cannot be distinguished from each other." Simply put, all black holes' features are identical, blurring distinction. Given that only mass, charge, and momentum were detected in this study, it seems black holes indeed have no hair. And this once again serves as evidence for the correctness of the general theory of relativity. That being said, it doesn't mean that black holes will never have hair for good. It's just another day passing with black holes in a hairless state. The gravitational wave that generated the first black hole collision sound in history was caused by GW 150914 that occurred in September 2015. Scientists converted these gravitational waves into sound waves, and it sounded like water drops. During the merger of the two black holes, the resulting black hole briefly emitted subtle gravitational waves into its surroundings. This phenomenon is referred to as ringdown. Ringdown refers to the gravitational waves that occur right after the peak of the waves caused by the collision of two black holes. Through ringdown, scientists can observe the characteristics of the newly formed black hole. Until now, the gravitational waves were considered too faint to be detected or analyzed effectively. It was also predicted that in the past, ringdown signals would have contained more complex and overlapping sounds. Through recent analysis, we realized that it is rather tranquil water-dropping sounds. At first glance, black holes appear immensely massive and intense, but the sounds they produce are surprisingly clear and cheerful. In the future, more advanced detectors will appear for improved gravitational wave detection on Earth and in space. Then, we can better detect ringdown and listen to a wider range of sounds from black hole mergers. And perhaps, we may finally discover black holes with hair.